This is Talking Drupal, a weekly chat about web design and development from a group of people with one thing in common. We love Drupal. This is episode 383, Programming the Physical World. Welcome to Talking Drupal. Today we're talking about programming the physical world with Stephen Cross. Stephen is the founder of this podcast and a past host. He's also a Linux and Raspberry Pi enthusiast. Stephen, welcome to the show. Thank you for joining us for the last 4 weeks. It's been great having you.
Enjoyed it thoroughly.
What's not to enjoy, right? I am John Picozzi, solutions architect at EPAM, and today joining me as usual, Nick Laughlin, founder of Enlightened Development. Nick, how are you?
Doing great. Good afternoon.
Awesome. And now to talk about our module of the week, let's bring in Martin Anderson-Klutz, senior solutions engineer at Acquia and maintainer of a number of Drupal modules of his own. Martin, what do you have for us this week?
Thanks, John. This week, I thought we would talk about the Alexa module, which allows your Drupal site to respond to Alexa skill requests. Now, it's a module that was originally created in 2016, but last year in July of 2022, an 8.x-1.1 version was released to give it sort of Drupal 10 readiness. The module is officially listed as having maintenance fixes only, but it seems like the maintainers have done a pretty good job of proactively releasing or creating releases to make it work with major releases of Drupal as they have been coming out, so for 9 and 10. In terms of open issues, it only has 6 issues open, and only one of those is a bug, which actually has an RTBC patch against it. Module is currently in use by 31 sites, and the current maintainer appears to be Gambry, who also maintains a number of projects related to the chatbot API. So the way the module works is it really provides only basic integration, and the idea is that you would create sort of a custom module to sort of implement the specific functionality that you want to expose to that Alexa skill. There is an Alexa demo submodule that you can use as reference for sort of creating that custom submodule. I think it's also worth pointing out that this module was highlighted in the DrupalCon New Orleans Dries note, and also mentioned by Dries in a later blog post about cross-channel user experiences. Also, if you're interested in learning more about how you can use this Alexa module with your own site, there was a recorded session at DrupalCon Seattle about using the module to integrate Drupal with Alexa, and we'll have that link in the show notes. So maybe opening this up to the group, anyone have any thoughts about using Drupal with Alexa?
I have one thought right this second. I'm glad that I have headphones in because I have one of those devices here, and we've said the wake word about 6 times, so could be interesting. But
yeah, our listeners are not going to be happy with us. I mean, I think it's interesting. I'm glad it exists. Personally, I don't have any of those types of devices in my house other than my cell phone, which I have that functionality disabled. But I think I do think that it's helpful to have that ability to have integrations. I mean, and it's also novel enough that while I've never used it, as soon as you mentioned it, I remember the Dries note and the blog post about it. You know, I think it's also important to note that this isn't the kind of thing where you just install it and it just works, right? You also do need to make the skill in the platform on the Amazon platform. Like it's not just you install this and all of a sudden your site works with that tool. You know, there's additional work that needs to happen.
Yeah, absolutely. I mean, I think that being said, the really cool part about this integration is that all of sort of the voice recognition and then text to speech side of things you inherit. You basically get that for free because Amazon does all of that. So it's really still, more of like almost like exposing an API, that type of integration. So I think it's a pretty interesting, path potentially for making your content or your site functionality available in different ways.
So that's an interesting point, right? So this is providing a connection between Drupal and, Alexa's skills service. Cancel. I was trying so hard not to say it. I failed.
Bingo. Is that what
Yeah,
it is?
there you go.
Okay.
Everybody
John,
can cross
bingo.
that off their sheet. So the question there, I guess, is to Nick's point, right? You still have to create that skill on the Amazon side. Is this just like formatting the API endpoints on the Drupal side to be able to communicate easier with the Amazon service?
So what I'm about to say, obviously, I'll use the major caveat that I haven't actually had the chance to implement with this myself. I have an idea of something that I think would be fun to expose as an Alexa skill. But it's my understanding that yes, you create almost like an API endpoint that will accept a request, and then you provide sort of that, almost like the controller type logic to define how it's going to format that response. I believe you can also give it the ability, so if somebody asks for something, then you can ask almost like a clarifying question to collect additional data. And then once you have all of the data that you need, you formulate the response, you provide that in text form, and then the device will actually then read that out loud to the user.
I think one of the reasons why this is well maintained is the Georgia State Gov website, I think, uses this to help maintain their integration as well. I think mostly to help with a lot of like frequently asked questions type stuff and information dissemination, but I believe that this is how that's done, or one of the tools used for that.
Yeah, Martin, I'd like to congratulate you on tying this into this podcast once again, the module of the week. So it's about interacting with Drupal from outside of Drupal. And I would like to challenge any of our listeners to go out and create an Alexa skill that you can say, Alexa, play the latest Talking Drupal podcast. And then we can figure out how to stream that to our listeners.
It's a great idea.
Yeah, it could be interesting.
Feel like I could probably do that right now just by saying those words, but
yeah,
I
maybe.
don't know. I don't know if that would work.
Yeah, I don't know. It probably would. I think if you said, Alexa, play the latest Talking Drupal podcast on Spotify, it probably would work. Oh, sorry, that's me. Alexa, cancel. Sorry.
I know in my car I can use Google Assistant to say, play Talking Drupal, and it'll spin up the latest episode on Spotify. So
yeah,
depending on your setup, there are definitely ways to do that, probably without a special skill. But I'm sure our listeners can come up with some interesting ideas on how this could be leveraged for sure.
Well, Martin, as usual, thank you for bringing us another amazing module, very relevant to our topic. And now on to our primary topic. Let's start with a easy-ish question, right, Stephen? What is meant by our show title today? Programming the physical world. What are we going to be talking about?
So, we all program, like as web developers. We code and we interface with the browser, which interacts with the users. What I'm talking about here is a little different in that you're interacting with physical devices. So when you code, you can interact with something that's mechanical directly, and like turning on a bulb or reacting to a button getting touched directly, not going through some other interface or some other environment, but you're interacting with the physical thing directly. And that's probably not super clear in that description, but it's coding something that's physical directly.
So my question is, how do people usually interact with programming the physical world? As you mentioned, as web developers or if you just ask a layperson if they're interacting with programming, they'll think about opening an application on their computer or a game or opening a website or app on their phone, maybe. But as you kind of hinted at, there's programming in all aspects of our lives. What are some examples of ways that people might be interacting with something that somebody programmed that they may not think about?
Yeah. So let's take the example of like maybe a microwave oven. I think is a good example. Is that when you think of your microwave oven, it's just a device or it's an appliance that's sitting in your kitchen, and um, you turn it on, you push a timer, and there's a time that goes on, and you open the door, it shuts off. There's a light that comes on. There's a fan that runs when it's running. All of that programming that's in there and that interaction is what I'm talking about in the physical world. So it's interacting with physical devices and things that you can touch and see, and motors and fans and lights and microwaves, those kinds of things. So that's sort of what I mean by the physical world. And when you think about your microwave, you actually don't think of it as someone that programmed that, right? You like look at your microwave oven and it just runs. But behind that microwave oven, there's code that's running that when someone pushes the start button, there's things that are happening, like the lights turning on, the spinner. If you have a spinner that's spinning your food around, that's running. And at some point, there's like a trigger that happens if someone opens the door while it's running. There's an interrupt that happens, and all that stuff stops.
Yeah.
That's the stuff that I'm talking about.
I mean, it's interesting to think about that for a second, right? Because you raise a great point, and the microwave is an interesting, an interesting example. I also was thinking of like my washing machine. Like when something goes wrong with your washing machine, you get like an error code, like F1, and you're like, okay, what does
Yeah.
F1 mean, right?
Yeah.
But like, the idea of opening the door, right? In my head, like I always thought that was a physical interaction, right? Door opens, latch trips,
Well,
sends signal
it
to
is,
something that shuts
Exactly.
everything
The
off, right?
send
but
signal to
it is.
something, John, is the key. Yeah.
Well, in the case of something that's safety oriented, like a
Yeah.
microwave, it probably is a physical switch, right? So when you
No, it
pull
is.
it out,
Yeah.
it's
Yeah.
disconnecting the connection that sends power to the transformer, most likely.
Yeah.
But that's still part of the programming, right?
Yeah.
Because it say, for example, it stopped like the pieces that it does that are part of the programming, most likely, aren't the actual physical shutting off of the transformer. It's the pause, beep, and pause the countdown, right?
But so,
Um,
I mean, there's also another part of that, right? And this is kind of where, as Stephen was describing it, my head was going as well, is like something we just talked about with the module of the week, right? Is virtual assistants, right? So like you can tell your virtual assistant to turn a light on and it'll turn a light on, right? So that's is that kind of similar to what you're thinking of, Stephen? Or
Yeah.
is it
Absolutely. Sure.
yeah.
Sure.
Okay.
So behind basically all of the things that we use today, it's hard to say all of the things. Most of the things we use today in our homes that do something are controlled by some code somewhere.
Right. So I
And
guess I'll
and access to that code and like learning how to use that code is something attainable and is really accessible to people, um and which is something that I've been interested in. I mean, I've been on the show like for a few episodes over the last few years. That's a joke. And one of the things that I've talked about in the past being on the show is like I've been like interested in Raspberry Pis, and my day-to-day job is Drupal and I love it. I love that coding. But I've learned over the last few years that there's another area of coding that you can interact with things on a more rudimentary or raw basis through this physical programming, which is very different from interacting with the entity API in Drupal.
yeah.
That's kind of why I wanted to talk about this a little bit today.
so that actually reminds me, and this actually came up in I think it was on Twitter, maybe recently, our show about Home Assistant, right? And in that show, you talked about, and we might talk about this a little bit more on this show, but you talked about, a light or a thing you set up to kind of monitor your dryer or your washer or something to
Yeah.
that effect, right? So like clearly there's programming around us everywhere, right? Everything you just highlighted this, illustrated this perfectly, right? Even a microwave
Mm.
like has some sort of programming. Your iron has some sort of programming to say like, oh, if it's not being used for 10 minutes, shut it off, right? How are we focusing our topic today? You touched on this a little bit with like how you're interested in this, but like how do you specifically think we're gonna kind of focus this to talk about this topic?
Yeah, I'd like to focus this around what it takes and how accessible is coding the physical world from working with a microcontroller. And that sounds like to me, if I was like thinking about this topic 3 or 4 years ago, that would sound like foreign to me and not accessible in any way and just strange.
Almost daunting, right?
Yeah, daunting, and just like no interest to me. Necessarily seems too hard because it seems like assembler coding and just doing things that are far away from the code that I do on a day-to-day basis when it's actually not that at all. I think it's very close. The coding concepts that are around working with a microcontroller and checking the temperature and humidity in your basement and making decisions about turning your humidifier on and off are things that are accessible and things that you can code and use the skills you have today. But it's also like a way to learn new coding skills that you don't have.
Yeah.
And it's not super hard to do. And the world that we live in today, there's companies out there that have created environments for us to really make this easy to learn.
So before I move on to kind of the next question that I have based on that, what is a microcontroller? Can you tell our listeners what that is?
Yeah. So I think the best way to describe a microcontroller is to talk about what it isn't in some way, right? And
Yeah.
bring people into like what they understand. So we all understand the computer on our desk. And I do think over the past 10 years, people have gotten to understand what a Raspberry Pi is and what a single board computer is. So if you think about a Raspberry Pi, it's a single board computer, which means it's a single board that has a CPU on it and has all the electronics you need for a computer on a single board. So you can plug a keyboard into it, you can plug a mouse and a monitor into it, and there's a CPU, and you install an operating system on it. That's what a Raspberry Pi is. So it's basically a smaller version of the computer that's either in your laptop or on your desktop. What a microcontroller is it's those things minus access to like a computer, keyboard, and mouse. It has a CPU, but the CPU is a single purpose. There's no operating system. So a microcontroller has basically single purpose software on it that you've written to do one particular task or a group of tasks, but there's no operating system. There's no external devices. You have access to connect to the outside world through pins, but it's not a general purpose computer.
And probably
So-
the most accessible types of microcontrollers out there for people are Arduinos, right? So Arduinos are kind of the Raspberry Pis of the microcontroller world, I think. Is that a fair comparison?
Yeah, I think that was a fair comparison a couple of years ago. So Arduino is known for making microcontrollers. So these little tiny single purpose system on a chip devices that you could use to program lights and in
Yep.
temperature sensors and fans and all that kind of stuff. Um, and over the past 2 years, 2 to 3 years, there's been that group has expanded. Actually, Raspberry Pi has gotten into that business,
Yep.
which is why I brought them up earlier. They created a device called a Raspberry Pi Pico, which is a microcontroller. A microcontroller, when we think of a microcontroller, it's a tiny board. Like if you think of it as like maybe the size of a piece of gum, a
Yeah.
stick of gum. If anyone knows what a stick of gum is anymore, actually, or
Yeah.
smaller. And on that
Quarter.
is
Yeah.
and on that is a chip, which is a system on a chip, an SoC, and it provides some functionality. And the Raspberry Pi Pico came out during COVID, I think in 2020, maybe 2021. And it was sort of Raspberry Pi's answer to the Arduino environment, which basically gives you the ability to program things for this physical environment.
I just want to call it too. One of the real advantages of microcontrollers is, aside from the ability to kind of make a single purpose use case or something, is they're very low power. Because they're single purpose, they can be very quick. They're generally local only. So, for example, a good example of a single purpose one, a microcontroller is like a thermostat, right? All it needs to know is the temperature above, usually two or three things. Is the temperature above this temperature? If yes, open this relay. Is the temperature below this other temperature if you have cooling?
Yeah.
If yes, then open this other relay, or vice versa, right? So it just needs to know if it's too hot or too cold, and then depending on that, which one to open, right? And so all it needs to do is every once in a while say, hey, what's the temperature? Okay, is that temperature too high or too low, right? So it doesn't use a lot of power. I mean, these types of devices, especially if they're battery devices, their battery can last for a year, 2 years, 3 years on just a single, watch battery, right?
Yeah,
And the fact,
so low powered and very fast too, because
yeah,
with a single purpose, there's no operating system running. So if you think about a computer or Raspberry Pi, there's an operating system running that's like sitting there running all the time and looking for interrupts and doing actions. In a microcontroller, it doesn't necessarily work like that. There's no OS involved. So any actions you do on it are direct, low powered, and very fast, extremely fast.
yeah, as long as you code them right.
Sure.
which is always the caveat, and no matter what level you're programming at.
So,
John, do you get what a microcontroller is versus a computer? Does that answer your question?
Yeah. I was actually going to try to simplify it even
Sure.
further, right? So, like the way I look at it is, it's like a light switch, right? There isn't a light switch has pretty much a single purpose, right? Turn the light on, turn the light off,
Mhm.
based on somebody doing something, flipping the switch, it does that thing. Now, granted, anybody that knows electricity or electrical systems like knows that a light switch has wires going to it and like what it's doing, right? But like at a very simple level, like this is doing the same thing. There's no OS on it. It's basically you're writing hey, if you get this input, do this thing, and it's just doing it for you, right? One other note, I think that, or one other point of clarification here on the microcontroller is microcontroller has a port that you're jacking into some way, or is it based on the images? It looks like maybe you connect it to a board in order to kind of apply your programming. Is that accurate?
Depends what it is.
So yeah. So let's talk about microcontrollers in terms of things that are accessible to developers and the things I'm talking about, right? So the microcontroller that you have in your microwave oven is not exactly the same kind of microcontroller that I'm talking about today. I'm talking about microcontrollers as development boards. So you buy a generic microcontroller, so a Raspberry Pi Pico or an ESP32. It's something that comes to you and it has a port on it, like a micro USB port or a USB-C port or something in it that you can interact and install code onto this microcontroller.
Mhm.
The idea of these development boards is it gives you as a developer an opportunity to like test this out and run your code and design the system that you want to design, that maybe you would launch into a product later on this development board that has a lot of capability. At the end of the day, if you were actually building a microwave, you would then design a microcontroller chip that was very specific to the microwave oven that you were installing it into. It wasn't one of these development boards that
Mhm.
you can easily install code on. So to answer your question, John, yeah, so like there's like two microcontroller boards that are probably the most useful today in terms of people trying this out. One I've already mentioned is the Raspberry Pi Pico, which is the one I would recommend people to purchase, to try this stuff out on. And I can talk about more of that a little later. The other one is an ESP32, which is another very popular one. Nick mentioned it. Arduino is a place that it started. Um, Now these are two very competing microchips that have lots of capabilities, including, you can go onto Wi-Fi with them today. So you can interact and create a device that's an IoT device. You can interact on your local area network and do things online and things like that.
The other, I think, really important thing to call out is that these components are generally the smallest component needed, so they tend to be a lot cheaper too, right?
Mhm.
So if you're looking for example, a temperature and humidity sensor, right? If you're
Yep.
going to buy yeah, like an Ecobee remote sensor, right? You're going to pay $50 to $75 for a package of two
Yeah.
of them. It's using a microcontroller inside, and connecting. But if you get just the temperature and humidity sensor directly, you can get them for like $3, $5, right?
Yeah,
And
it's
and
good.
you need to connect it to the microcontroller, program it yourself. But if you're putting 100 in your house, that's going to be significantly cheaper
Yeah.
than than buying something off the shelf.
So to give people an idea of just price, like when I'm talking about you can buy a microcontroller and start programming it tomorrow, a Raspberry Pi Pico is $5. The one that has Wi-Fi and Bluetooth in it is $6. That's what we're talking about here in terms of I can actually buy something for $5 a Pico. I can write Python, C code on it, run it, and have it interact with physical devices and not have a lot of outlay in terms of financial investment. Nick just mentioned checking the heat, in humidity or temperature and humidity. I just had a device come in the last few days that I purchased, which is a high end, temperature and humidity sensor, and it was $12.
Yeah.
Like that's like the high end version of this. So it's kind of interesting that you can buy these little things, connect them and program them, and there's not a lot of outlay in terms of cash, in terms of understanding this technology and playing with it.
So I
Yeah.
was gonna save this question for later, but I think
Yeah,
I'm gonna ask it now because it makes sense, right? So supply chain issues, we've all heard like,
huge.
chip manufacturing is not not exactly the easiest industry to be in right now. People are having issues getting chips. Are you seeing issues in getting microcontrollers and getting some of these sensors?
Yeah, great question, John. So anyone in the Raspberry Pi world has known that basically Raspberry Pis have not been available for almost 2 years. You cannot buy one, or if you go to eBay to buy one, you could pay tenfold of what it really costs. The interesting thing is, it never impacted Raspberry Pi's Pico delivery. So,
Mhm.
which is funny is how I actually started spending more of my time in microcontrollers over the last couple of years is because I couldn't get any more Raspberry Pis at a reasonable price. They were unavailable. So I bought a few more Picos and started playing with them and then realized, oh, this was far more fascinating to me than was the Raspberry Pi at a whole. So the microcontroller Pico has been available, mostly. A little bit, maybe not so much 2 years ago, but totally available now. And I haven't seen. And listen, this is a hobby for me, so I wouldn't say I'm the insight on availability of microcontrollers over the last 2 years, but I haven't seen it be a problem in the microcontroller world.
Well, one of the things though too is that microcontrollers are an old technology, right? They've been around forever. So one of the explanations I've seen on it is that it's older tech, and a lot of the manufacturing stuff is up. A lot of the harder to get stuff is because there's something unique in the manufacturing process for it, and it's hard to get that. Or they're using those chips for something else that's just willing to pay more. For example, like maybe I don't know specifically, but for example, the Raspberry Pi might be using a component that cars are also using because it's higher order, and car companies are just going to pay more for that part. And
I think, well, no,
than
like,
Raspberry Pi.
well, looking into, like, knowing what's going on with the Raspberry Pi. So Raspberry Pi, they started 10 years ago as like a hobbyist in an educational environment, as the single board computers. What happened was in the past 6 or 7 years is that companies have learned that these computers are awesome and started putting them into manufacturing products and stuff. So what Raspberry Pi did, as the shortage started to happen, they started to focus any products they developed and they could get through the pipeline. They were moving them through their commercial pipeline. That's what was going on. So the end user couldn't get the Raspberry Pis, but
I understand.
commercial vendors and manufacturers who were using them in their industrial products were able to still get them.
And the pipeline for the lower order microcontrollers
Exactly.
is huge,
Yeah.
so they
Yeah.
can handle the demand for consumers as
Yeah.
well.
So
That
they
makes
went to
sense.
their most important customers first, I guess is how you'd put it. But you said old tech a little bit, but the Raspberry Pi Pico has got a microcontroller, the RP2040, which is a brand new microcontroller chip that was designed by Raspberry Pi 2 years ago.
Yeah, to
Yep.
clarify, what I meant by it is like process control systems and like manufacturing and microwaves and things have been using this type of technology for years. Not
Yeah,
that they haven't improved them
right.
incrementally, or there's been new things, but in general, these types of components have been around and in use for a very long time.
So I edited our next question, right? Because we've already talked about like the vast array of things you can use a microcontroller for, right? And I think people can be pretty creative as to like what they could get one of these and use it for. So the edit to it is like, what types of things wouldn't you consider using a microcontroller for? Is there anything that comes to mind where you're like, oh no, like don't use a microcontroller for that?
Interesting question. I would not try to run the Drupal site on a microcontroller.
Well, right. So I mean, I think we established that, right? Like it's very
Yeah.
that it's kind of low resource intensive sort of
Mhm.
stuff, and kind of like very strict in the kind of like take in an input, get out, and take in input, get an output sort of thing, right?
So when you think out on control, just to put in perspective here, we're talking about a very small computer CPU device that has maybe 64 to 56K of RAM. It may or may not have some flash memory, and it has circuits that interact with outside devices. So there's lots of places a microcontroller does not fit whatsoever.
So let's say you're interested because of the show, you want to get started. What kind of languages are microcontrollers usually written in, and how do you program them? Like, how do you physically get your program onto them?
Yeah, great question. So
Magic.
it's magic. So I think there's the development, like learning side of the microcontroller, and then there's the production. I'm going to put it in a microwave oven version of that, which I'm not going to discuss. But basically, microcontrollers today, the two that we've talked about in general, the Pico and the ESP32. These are controllers that you can write micro Python for, C, C++, and assembler.
Okay.
Are really the languages that you're using. And the reason why I recommend starting with the Pico is because it's really easy to get up and running. The Raspberry Pi Foundation, who is really educational based, like they're trying to get people to understand technology and breed our next generation or two of engineers. They've made it very easy to program a microcontroller. Basically, you plug this through a USB cable into your computer. You fire up probably the most common IDE for it is called Thonny, Thonny, Thonny. You fire up this IDE and you get up and running in 5 minutes. You can write a MicroPython program and have it running on the Pico in under 10 minutes.
What was your first program then on a microcontroller?
That's a good question. I think one of the early things I did was when I moved away from Raspberry Pi, I started to play around with interacting with APIs online. I think I showed you guys this at some point, which was I had a display on my desk for a while, which was an LCD that was plugged into my to-do list, which is Todoist that I use for my to-dos every day. And it was calling the API online for Todoist and displaying my open tasks on an LCD on my desk. So I could constantly see the tasks that I needed to complete that day.
Sounds stressful.
It does sound stressful, but it was more of a love for like figuring how this worked and making it work.
So again, our next question is the average person, right? How do they, could they get a microcontroller and program it? It sounds like from our conversation, right? Yes, they could. So let's enhance that question a little bit and say, like, how do you think somebody would kind of get started with this if they wanted to get into this sort of thing?
It's really easy. And a Raspberry Pi Foundation has made that easy you basically buy a Raspberry Pi for the $5. And then all of the documentation that's available for you, Raspberry Pi like creates these books that's like, learning the Pi Pico. It's a physical book you could buy, which I don't think is available right now. It's sold out. But all of the documentation is always available online and through PDF. So you could buy a Pico for $5 online. Don't go to Amazon. Go to raspberrypi.org. I think it's .org directly.
There's a link in the show notes.
Okay. Yep. And buy a Pico. Go to their website, download the book that takes you right from the very beginning, because there's a couple of things here. One is when you're starting to do this stuff with the microcontroller, there's lots of things you're learning. One is the programming side. The other is the electronic side of this, right? So as you're starting to interact with other physical devices, you need to learn a little bit about basic electronics. Like, what is a resistor? When I plug these things in, how do they work? 5 volts versus 3 volts. How do I make this stuff happen? There's these different communication protocols with a microcontroller, I2 squared, and these things you need to learn. And it's all fun to do. really interesting. And the the documentation from Raspberry Pi walks you through that stuff. So that's how I would recommend people starting. There's tons of resources out there as well to learn this kind of information.
So let's say you come up with a use case. Like one thing that I've been thinking about dipping my toe into this for quite a while actually, and maybe this will inspire me to actually do it. But w- let's say I come up with a use case. I want to get more temperature and weather sensors around my house,
Mhm.
right? And maybe outside in the shed too.
Yep.
I get the components that I need. I figure out the programming, get it on the controller. How do I package it up and so that it's like ready? Like I'm not going to produce a product, right? But I still want it to just not be a bare board, just like taped to a wall, right? How do you package it up? Are there
That's
are
a good
there
question.
containers? Do you just get a
Yeah.
3D printer
That's,
and figure it out? What do you do?
yeah. No, that's a good, that's a great question. So Nick is saying like I've got these little controllers, and for anyone listening here or watching here, like here's an example of one. I've got this little board sitting that's like a half an inch by an inch, and I'm connecting it all these wires. How does that facilitate itself into a product? Right? Is your question?
Yeah, and like I said, more specifically for personal use, right? You're not
Yeah.
producing
No, no,
something to
no,
sell.
exactly. Right. So there are lots of resources. So if you're into 3D printing, this is your like space because
Okay.
there's lots of designs out there that you can download and 3D print containers and boxes and all kinds of things, frames to put stuff in. I haven't done that. So my stuff has been way more rudimentary. So I spend time at Michael's and places like that and buy
Oh,
these wood frames that fit stuff in, and I tape them in, and I build things myself mechanically through these little things I find at Michael's. Generally is the way I
hmm,
make my final products work. If you look in my basement, I do have my humidity and temperature sensor is basically these things taped to a wall, which isn't super attractive, but it works fantastically.
I keep going back in my head as we're talking to um, the kind of like getting into this, right? And my previous question was like talking about the average person, right?
Mhm.
I'm hearing, obviously we all have some sort of coding background, right? We also, there may be like some of us have a little bit of electrical background. Stephen just talked about like a 3D printer, right?
yeah.
Being into that. Like, do you see like if somebody is listening to this show, and I think you answered this in kind of a little bit in the last question where you said like start with the Raspberry Pi because it kind of takes you from like nothing to something, right?
Mhm.
Um, do you see that as a path for somebody like for somebody like say I don't know, a librarian or somebody that's like completely not into the tech space or into programming, like is that a good path for them to get started with this?
Yeah, it totally is. So you don't really need any expertise to do to get to the starting point of this. You need very minimal outlay in terms of buying stuff. Um, One of the things that people often ask is, do I need to learn how to solder things? Like I'm dealing with electronics. So no, you don't, because um, there's this thing called a breadboard. Um, it's a way to connect electronic devices without doing any soldering. Um, and it's a way for you to like learn. You need to buy maybe 4 or 5 things: some wires, a breadboard, a microcontroller that has headers. So a header is like these little pins that stick out of a microcontroller you could plug into a breadboard and then connect all your other devices. So you can launch into this in terms of learning and experimenting without knowing a whole lot. and
Okay.
not be in fear of like doing anything damaging or fear of electronics.
And the investment, the monetary investment is pretty low too. So even if you do, you mentioned voltages earlier. If you connect 5 or 12 volts to something that needs 3 volts, you might fry something. But if you do, you're just losing like what, $2? It's not.
Yeah. It's low.
It seems a lot cheaper than most hobbies.
It
Yeah,
is. Yeah.
Compared to if you fry a Raspberry Pi or something, which is really hard to replace and quite a bit more expensive.
One of the things I just wanted to mention on the programming side is that from our perspective, coming from a Drupal side, like in Drupal 8 and Drupal 9, object-oriented programming is the way Drupal went when it went to 8. One of the things that it's been really interesting to me working with microcontrollers is that Python is a object-oriented language, as is like obviously C++. And if you're struggling learning object-oriented programming, a great way, I think, to get a grasp on that is to work in this physical world where, a lot of examples you see in object-oriented programming for PHP or any of the languages, like you come up with these objects, and these objects are always things that you can't see and touch. They're things that don't really connect to you in some way. But you can, in the physical world, you can actually create an object that is a light bulb, right? Or in my example I gave earlier, which is a microwave, which is something that I built. So I built this using a microcontroller, built this microwave oven that is not really a microwave oven, but I created these objects for a fan and a light and a door. And I could actually really get a good sense of what objects meant when I could actually see them and touch them and make them turn on and off. So it's an interesting way to learn the object-oriented world by coding a microcontroller using object-oriented programming.
I was thinking that's why Steven was wearing a hat today, because he fried all his hair off with a microwave.
Well, before we move on, actually, that raises another question. Is so you mentioned you're using MicroPython, and you can also use C++ or C, and those last two are compiled languages, right?
Yep.
And Python typically isn't. Is MicroPython? Do you have to compile for MicroPython to go on?
No. So you don't compile the MicroPython to run on the microcontroller, but when you use assembler or C++, you do compile it and then push it to the board, so it's running compiled code. So like if you see microcontrollers that people are implementing real solutions with, they're generally using C++ or assembler to get to the final product.
Yeah.
Right. For performance reasons, right?
Yeah.
But a good way to start is with the MicroPython gives you the sense of what it is. And I've been doing stuff in C++ too, to see the difference and comparing the C++ versions versus the Python versions to see what the difference is. So yeah. So
just to clarify, those compiled languages, like that is something that you have to be familiar with, and you have to compile those before you put them on the chip, right? There's no like process in place to like compile those as they go.
No, so like in the C++ or the assembler, or you compile them on your PC and then you push the final code to the microcontroller.
Yep.
So it's like an additional step. So people starting with this, like Python and MicroPython is a great way to start to get the feel for it. If you like get serious and want to like test things out and see what and push things in the real world, because there's lots of manufacturing products that are using this Pi Pico. This, like, it seems it's $5. It seems like who would use this? It's being used in tons of products today as like a real world solution to implement physical things, and you could learn how to code that. Those things are probably implemented in C++ at the end result, but people started in the MicroPython side.
Interesting. So you mentioned Drupal a few seconds ago, and you did
Yeah.
say that you wouldn't run Drupal on a microcontroller.
No,
So how do microcontrollers relate to Drupal, or is this just a hobby and you wanted to talk about it, and that's why we picked the
no,
topic?
that's fine. That's a great question. And it is a hobby, and I love to talk about it, which is why I'm glad I had a guest host spot to talk about this, because I used to have this outlet years ago. Um, but you guys have spent a number of episodes in the past few months talking about like interacting with Drupal outside of Drupal, right? The
Mhm.
last few
Yeah.
episodes you talked about Gatsby. Microcontroller is Gatsby, if you think about it in a way, right? It's basically interfacing with Drupal outside of Drupal. So a microcontroller that has internet access could very easily start up an interface with a Drupal API. So think about something like, I have a manufacturing plant and I want to put these LCDs into the plant that gives current statistics about what's happening in our production environment. And you run Drupal, you could very easily use a microcontroller connected to an LCD interface and query a Drupal API to find out what the current production stats were and display them to people.
And you can have it on the. It sounds like you could have it on the other side too. So you could have a microcontroller that's measuring at the production line what's happening, and then just feeding that information back into Drupal as well as kind of the
Works both
repository.
ways. Yeah, works both
Okay.
ways. Exactly. Yeah.
Wonder if anybody's doing that. Somebody's got to be doing that somewhere in the world with Drupal.
There's no question about it. Yeah.
Curious about that.
Now I'm thinking of all the different ways I can interact with microcontrollers on my Drupal site. But so let's just talk, and we've talked a little bit about this already, Stephen, but like, how have you used microcontrollers in the past? I mean, you just told us, obviously you have humidity detection and whatnot in your basement. We talked about, your washer and dryer setup. Are there any other ways that you've used these microcontrollers in your past, in your house, outside of your house, so on and so forth?
No, I think that covers it. Like, so I'm a hobbyist at this, right? But it's super interesting to me. I've been using microcontrollers probably the last 3 or 4 months, more about learning about technology a little bit more. So, for example, the Raspberry Pi Pico has a CPU on it, the RP2040, that has 2 cores. So I've been playing with writing code that executes against 2 cores instead of one. So just because of the things I'm interested in, that's something I'm playing with. It doesn't give me anything at the end, but I'm learning how to code multiple cores instead of one.
Is a core synonymous with a code base?
No, so if you think of CPUs, so when you're talking about a CPU, a single core CPU has one thread of execution code. When you have multiple cores, you can run multiple things at one time and see how they interact. So performance, so to increase performance, is why multiple threads or multiple
see.
cores would be used.
So
Yeah.
instead of doing things linearly, you could do like
Yeah.
do this and then
Multiple
do
at one
this,
time, right,
compare,
yeah.
come back, and
Well, it's kind of like You can a really kind of simplified way of thinking about this is PHP versus JavaScript, right? If you do something in PHP and then do something else, the first thing's always going to happen first. The second thing's going to happen second. If you write code in JavaScript, just vanilla, everything's going to execute at once. So you need to account for the asynchronicity, or you have to tell JavaScript, hey, do this, and then wait until you get the result before you do the next thing. It's the same thing with multiple cores. If you just have one core, things are going to execute in order. If you have multiple cores, you have to make sure that you're executing things that can actually be executed in parallel.
Yeah,
Otherwise,
that's a great description. I think, Nick, at a high level, the difference with dealing with a microcontroller is you don't have an operating system that's in between. So when you're dealing with PHP, the operating system is actually making decisions about who actually executes in the CPU, um, and the interrupts and making things happen there. When you're dealing with a microcontroller, you have direct access to the CPU. So you are controlling yourself in the code, the interrupts, and what happens when. So those are the kinds of things, John, I've been playing with over the past 3 or 4 months, is just getting a better understanding of how computers work and how technology works. Um, there's actually some projects out there for microcontrollers, that people have written operating systems that run on a microcontroller, which
Oh wow.
is
That's
super interesting because it gives you a real interesting feel about how an operating system works.
yeah. And
So in general,
the performance must be terrible on those operating
no,
systems, though.
actually, the performance is not terrible,
Oh, really?
because it's like when you're coding in a microcontroller, you're talking to the hardware directly, right? It's not, there's no layers in between. So
Mm.
it's an interesting way to learn about how technology works, which is how I'm using it. I think it's a great way to learn more about object-oriented programming. Great way to learn more about how computers work in general.
How much space is on a microcontroller? So like if you have like a program and it's, rather large, right? Like do you run a risk of like basically running out of space?
Yeah, sure. So it's very small amount. Like we're talking about um 256 megs of, probably like I think in the Raspberry Pi it's 256 megs of RAM that you can put something into. So
Oh, okay.
we're talking about going back 20 years, 30 years in terms of um,
Processing.
resource availability.
Yeah, but I
Yeah.
think again, like a simplistic way of looking at this in my brain was like, oh, it's a small chip, so it's going to have like, kilobytes of data.
No. It's not
As
kilobytes. Yeah.
opposed to like be like 256 is like, okay, that's like a good amount of space, especially when you're coding, in something like C or Python.
Yeah.
So, as we wrap up the show, I think we've recommended if somebody's getting started, they probably should look into the Pico or maybe the ESP32.
Mhm.
And you mentioned the Raspberry Pi Foundation has some good articles and things, but are there any other recommendations for people just getting ready to start? Any blog posts they should read to get primed, or like the best place to find, like you mentioned, a breadboard? Like, how do you know all the different component pieces you need to get started?
Yeah.
Where's that?
We'll put this in the show notes. I cannot recommend more. Just the Raspberry Pi documentation, their getting started books. I'll put a link in the show notes. Is really the best place to start because they take you on the journey from zero, and get you there. And the investment is small, and their documentation is written for people who know zero, which was me, a couple of years ago.
And now, are they? I mean, I'm assuming they're giving you code examples like, "Hey, you're doing this, so here's the code that you would use to do that." Are they also teaching you like the Python basics so that you can kind of
Yeah,
get familiar with it? Okay.
yeah. They're doing all of that. Yep.
Oh, cool. Interesting. Well,
You could
Stephen,
you could also you could also if you're local, you could go to Nerd Summit, which is coming up in March, and I'm going to be doing a microcontroller introduction training there.
and when he
Well,
says local, he means the New England area, as Nerd
Thank you.
Summit is in Western Massachusetts.
Yeah,
So, you
check
can
that out.
definitely check that out. Is it a full day training, half day training?
It's a half day.
Okay, cool.
I think we only need 3 or 4 hours to get someone really up and running with a microcontroller, a breadboard, some wires, and a few components. And you could like get started with this and see if there's something you're interested. For anyone out there with young children, what I mean by young, so maybe late elementary, middle school, this is really something if they're interested in to get them started in. It gets them into electronics and engineering early. It's easy, accessible. They can see things, get results quickly. a great way for them to, if you want to steer them or if they're interested in that direction.
Interesting. Something to think about as I have somebody that fits that criteria in my house. Stephen, as always, thank you for joining us for the last 4 weeks. This topic has been super enlightening, and we will definitely hear from you again.
And for our listeners, if you have questions or feedback, you can reach out to Talking Drupal on Twitter with the handle Talking Drupal, or by email with show@talkingdrupal.com. You can also connect with our hosts and other listeners on the Drupal Slack and the Talking Drupal channel.
You can promote your Drupal community event on Talking Drupal. Learn more at talkingdrupal.com/tdpromo.
And you can get the Talking Drupal newsletter for show news, upcoming Drupal camps, local meetups, and much more, including a picture of Stephen's basement humidity temperature sensor at talkingdrupal.com/newsletter.
Thank you, patrons, for supporting Talking Drupal. Your support is greatly appreciated. You can learn more about becoming a patron at talkingdrupal.com and choosing the Become a Patron button in the sidebar. All right, gentlemen, we have reached the end of our show. Stephen, if folks wanted to get a hold of you to talk about microcontrollers or anything else for that matter, how would they go about doing that?
At Stephen Cross on Twitter with a PH.
And Nick, what about you?
You can find me at NixVan, NICXVAN, pretty much everywhere.
And I'm John Picozzi. You can find me on all the major social networks at John Picozzi, and you can find out more about EPAM at epam.com.
And if you've enjoyed listening, I've enjoyed talking.
Have a good one, everyone.
See ya.
See ya.